estimating the cost of installing a 40-amp, 12-bay subpanel approximately 140 feet from the main panel, inside a pole barn with a wall separating them, using number 6 nm cable, stapling to the barn rafters, and working off of an extension ladder involves considering both materials and labor. For materials, you'll need approximately 280 feet of number 6 nm cable. The amount is double because it's 140 feet away, needing one to feed and one to return, a 40-amp subpanel, conduit and fittings if required, staples, and an extension ladder. The labor component consists of 3 primary tasks. Firstly, running the cable, which is estimated to take 2 to 3 hours depending on accessibility. Secondly, installing the subpanel, which is estimated to take 1 to 2 hours. Thirdly, terminating the cable and connecting the subpanel, which is also estimated to take 1 to 2 hours. This brings the total labor time to an estimated 4 to 7 hours. The going rate for electrical installation in Ohio typically ranges between $60 to $100 per hour. Therefore, the estimated total cost breaks down as follows. Materials are estimated to cost between $200 to $300. Labor is estimated to cost between $240 to $700 based on the hourly rate and estimated labor time. This results in a total estimated cost ranging from $440 to $1,000. However, several additional factors can influence the final cost. Firstly, the complexity of the installation, such as whether conduit is required, can impact labor time and material costs. Secondly, the availability of qualified electricians in the area can affect hourly rates, as higher demand may lead to increased prices. Thirdly, seasonality can play a role, with rates potentially being higher during peak seasons when electricians are in greater demand. It's important to note that this is just an estimate, and the actual cost may vary depending on specific circumstances. It is highly recommended to obtain multiple quotes from qualified electricians before making a decision to ensure you receive the most accurate and competitive pricing for the installation. When considering the installation of a subpanel, the selection of appropriate materials and adherence to electrical codes are paramount for safety and functionality. The choice of number 6 nm cable is suitable for a 40-amp circuit, but it's crucial to verify this with local electrical codes and the ampacity rating of the cable. The length of the run, 140 feet, necessitates considering voltage drop, which could affect the performance of connected devices. Voltage drop occurs when the voltage at the subpanel is lower than the voltage at the main panel due to the resistance of the wires. Excessive voltage drop can cause appliances to function improperly or even damage them. To mitigate voltage drop, one may need to increase the wire size, which would increase the material cost but ensure proper voltage at the subpanel. The installation of the subpanel itself requires careful attention to grounding and bonding. Grounding provides a path for fault current to return to the source, protecting against electrical shock. Bonding ensures that all metallic parts of the electrical system are at the same potential, further reducing the risk of shock. The subpanel must be properly grounded to the main panel using a grounding conductor, and all metallic enclosures and components must be bonded together. The use of conduit may be required by local electrical codes, particularly if the wiring is exposed or subject to physical damage. Conduit provides mechanical protection for the wires and can also serve as a grounding conductor if properly installed. The choice of conduit material, such as PVC or metal, depends on the specific application and local codes. Staples are used to secure the NM cable to the barn rafters, but they must be installed properly to avoid damaging the cable. The staples should be sized appropriately for the cable and spaced according to code requirements. Over-tightening the staples can compress the cable insulation, leading to shorts or ground faults. Working off an extension ladder presents safety challenges, and it's essential to take precautions to prevent falls. The ladder should be placed on a stable surface and secured to prevent movement. The electrician should maintain 3 points of contact with the ladder at all times and avoid overreaching. It's also advisable to have a helper present to assist with the installation and provide support. Obtaining multiple quotes from qualified electricians is crucial for several reasons. Firstly, it allows you to compare pricing and ensure you're getting a fair rate for the installation. Secondly, it gives you the opportunity to assess the electrician's qualifications and experience. Thirdly, it enables you to discuss the scope of work in detail and clarify any questions or concerns you may have. When interviewing electricians, ask about their licensing and insurance, their experience with subpanel installations, and their familiarity with local electrical codes. Also, inquire about their warranty policy and what steps they take to ensure the safety of the installation. Remember that the lowest quote isn't always the best option. It's important to consider the electrician's qualifications, experience, and reputation as well as the price. A qualified and experienced electrician may charge more, but they can provide a higher quality installation and ensure that the work is done safely and according to code. Ultimately, the decision of whether to proceed with the subpanel installation depends on your individual needs and circumstances. A subpanel can provide additional circuits and capacity for powering tools, equipment, and appliances in the pole barn. However, it's essential to weigh the costs and benefits carefully and ensure that the installation is done safely and according to code. Before commencing any electrical work, it is paramount to consult with local authorities and obtain the necessary permits. Electrical codes vary by location, and compliance is crucial for safety and legal reasons. Permits ensure that the installation is inspected by a qualified electrical inspector, who can verify that the work meets code requirements. Working without the permit can result in fines, penalties, and potential safety hazards. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations in the United States. The NEC is updated every 3 years, and it's essential to stay current with the latest edition. Local electrical codes are often based on the NEC, but they may include additional requirements or modifications. Some relevant NEC articles for subpanel installations include Article 250, which covers grounding and bonding, Article 310.15, which deals with conductor ampacity, Article 408, which covers switchboards and panel boards, and Article 384, which covers switchboards and panel boards. The selection of appropriate overcurrent protection is critical for safety. Overcurrent protection devices, such as circuit breakers and fuses, protect the wiring and equipment from damage due to overloads and short circuits. The size of the overcurrent protection device must be matched to the ampacity of the conductors it protects. In the case of number 6 NM cable, which is typically rated for 55 amps at 60 degrees Celsius, a 40 amp circuit breaker is appropriate. However, it's important to consult the NEC for specific ampacity ratings and dirting factors. The location of the subpanel should be carefully considered. The subpanel should be located in a dry, accessible location that is not subject to physical damage. It should also be mounted securely to a wall or other supporting structure. The subpanel should be labeled clearly to indicate the circuits it serves. The wiring within the subpanel should be neat and organized, with all conductors properly terminated and identified. The use of wire markers and terminal blocks can help to improve the organization and clarity of the wiring. Regular maintenance of the subpanel is essential for ensuring its continued safe and reliable operation. The subpanel should be inspected periodically for signs of damage, corrosion, or loose connection. Circuit breakers should be tested regularly to ensure that they are functioning properly. Any problems should be addressed promptly by a qualified electrician. Installing a subpanel can be a complex and challenging task, and it's important to have the necessary skills and experience to do the job safely and correctly. If you're not comfortable working with electricity, it's best to hire a qualified electrician to perform the installation. A qualified electrician can ensure that the installation is done safely, according to code, and to a high standard of quality. They can also provide valuable advice and guidance on the selection of materials, the location of the subpanel, and other aspects of the installation. Remember that electricity can be dangerous, and it's essential to take all necessary precautions to protect yourself and others from electrical shock. Always turn off the power before working on any electrical equipment, and use insulated tools and equipment. If you're not sure how to do something safely, ask a qualified electrician for help. In summary, estimating the cost of installing a 40 amp subpanel requires careful consideration of materials, labor, and other factors such as the complexity of the installation, the availability of qualified electricians, and seasonality. Obtaining multiple quotes from qualified electricians is essential for ensuring that you receive the most accurate and competitive pricing. The installation of a subpanel should be done safely and according to code, and it's important to have the necessary skills and experience to do the job correctly. If you're not comfortable working with electricity, it's best to hire a qualified electrician to perform the installation. Furthermore, remember to consider the potential impact of voltage drop, especially with longer runs of cable. As previously mentioned, voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source due to the resistance of the wires. This can be a significant issue with longer runs like the 140-foot distance specified. The NEC provides guidelines for acceptable voltage drop, typically recommending no more than 3% voltage drop for branch circuits and 5% for feeders. To calculate voltage drop, you'll need to know the resistance of the wire, the length of the run, and the current flowing through the circuit. Online voltage drop calculators are available, or you can use the following formula: voltage drop equals 2 times the length times the current times the resistance per foot, all divided by 1000. If the calculated voltage drop exceeds the acceptable limits, you'll need to increase the wire size to reduce the resistance. In addition to voltage drop, it's also important to consider the ambient temperature when selecting conductors. The ampacity of a conductor is the maximum current it can carry safely without overheating. However, the ampacity of a conductor is reduced at higher temperatures. The NEC provides ampacity correction factors for different temperature ratings. If the ambient temperature in the pole barn is high, you may need to select a conductor with a higher temperature rating or increase the wire size to compensate for the dirty. Proper grounding and bonding are essential for safety. The grounding system provides a path for fault current to return to the source, tripping the circuit breaker and preventing electrical shock. The bonding system ensures that all metallic parts of the electrical system are at the same potential, further reducing the risk of shock. The grounding electrode system, which connects the electrical system to the earth, should be installed according to NEC requirements. The grounding electrode system typically consists of a ground rod, a metal water pipe, or a concrete encased electrode. The grounding conductor, which connects the subpanel to the grounding electrode system, should be sized according to NEC Table 250.122. Bonding jumpers should be used to bond all metallic enclosures, raceways, and equipment together. The bonding jumpers should be sized according to NEC Table 250.102. Surge protection is another important consideration, particularly in areas prone to lightning strikes. Surge protection devices, or SPDs, protect sensitive electronic equipment from voltage spikes caused by lightning or other electrical disturbances. SPD should be installed at the main panel and at the subpanel to provide comprehensive surge protection. The selection of appropriate SPD depends on the voltage and current rating of the electrical system, as well as the level of protection required. Remember, this information is for general guidance only, and it's important to consult with a qualified electrician and local electrical codes before undertaking any electrical work. Electrical work can be dangerous, and it's essential to take all necessary precautions to protect yourself and others from electrical shock. Always turn off the power before working on any electrical equipment, and use insulated tools and equipment. If you are not sure how to do something safely, ask a qualified electrician for help.